Okay, this is the final and third part of the conservation of momentum lessons. And last thing I did was explain what elastic collision was, and we're seeing that the fact that momentum is going to be conserved, but and kinetic energy is also conserved. Now, in that case, then, what is meant by inelastic? Where you can have a total inelastic collision and a partial collision. To show you that, I'm again going to go back to this lovely bit of software. Now, what I'm going to do now, you might remember beforehand I had elasticity of 1 where they bounced off each other. What I'm going to do now is I'm going to take it all the way down to 0. What that's going to mean is when A hits B, they're going to stick together. So let's play the simulation forward, go across, and here they stick together. Now, if they stick together, we can start looking at momentum to see if it's conserved. Well, they both move off the end at 1, and initial momentum A is going to be 2 times 1, which is 2. The B is going to be 0 because it's got no speed at all. When they move away, the final momentum A is going to be 1 times 1, which is 1, and this one's going to be 1 times 1, which is 1. And you can see total momentum before is 2, and total momentum afterwards, 1 plus 1, is also 2. Momentum has been conserved. But if we look at the kinetic energy by using the equation half mv squared, we can work out the initial velocity of A is going to be half mv squared, which pops out to 2, and then initial kinetic energy of B is going to be 0 because you've got no velocity. Afterwards, because both moving at 1, we can then use a half mv squared. We get the final kinetic energy of A to be 0.5. Kinetic energy of B is also 0.5. 0.5 plus 0.5 equals 1. Can you see kinetic energy is not conserved? So for a total inelastic collision, the two trucks join together, momentum is conserved, but the kinetic energy is not conserved. Now, what's meant by a partial inelastic collision? Well, if I now take the elasticity down to 0.6, which is obviously in between 0 and 1, now what's going to happen when they collide is they will not stick together. A bit like elastic collision, but watch. When they hit each other now, bang, off they go. They don't join together. A moves forward and B moves forward. Now, if I look at the momentum before, initial momentum is going to be 2 of A and 0 of B, exactly the same. But now they move off with A moves off at speed 0.4 and B moves off speed 1.6. Now, if I work out the momentum afterwards, got 0.4 and 1.6. Again, you can see momentum has been conserved. Initial momentum is 2, and the final momentum is also 2. But now we look at the kinetic energy. The kinetic energy of A at the beginning was 2. B was obviously 0 because it wasn't moving. Afterwards, working the kinetic energy of A, you get 0.1, and then B, you get 1.3. Add the two together, you get 1.4. Kinetic energy is not conserved. So therefore, in a partial elastic collision, they don't join together, momentum is conserved, but kinetic energy is not conserved. So to summarize that for you, sounds like a mouthful and a half, is what is meant by a partial and total inelastic collision. Both of these is always going to have the total momentum must always be conserved in both of these. Okay? But if you had here a total inelastic together, they're going to join together, and they're always going to join together. And this one is the partial, is they do not join together. But your kinetic energy is not conserved in both. And they will ask you in exam questions the definition of these partial and total elastic, and also a elastic collision. So go with that then. These sort of calculations you have to do. So here, this comes in year 13 in kinetic energy. And when we start in year 13, you start to see these calculations come through, but you have to basically apply the principal momentum. So you've got a gas molecule, which is this one here, is 2.0 times 10 to the minus 26 kilograms. And it's going to collide with this one, which is going to be 10 times 10 to the minus 26 here. Okay, this one has got a velocity, first of all, and it's moving off with 600 meters per second. and this one, the velocity is initially going to be 0. Afterwards, we know this one is going to rebound with 400 meters per second. What's going to happen to this one? Don't know, but I'm going to guess it's going that way. Now, this is quite an open-ended question. It says, is this collision elastic or inelastic? Well, to do that, you've got to look at the kinetic energy before and afterwards. So the first thing you've got to do is you've got to apply the principle of momentum. So we're going to say the total momentum before is simply going to equal to the total momentum afterwards. And you always write this down at the beginning of your questions. Okay, so looking at the momentum before, well, in this one is I can take 2 times 10 to the minus 26, writing in. I'm then going to multiply it by my 600. That one is going to be 0. I'll still include it, but 0 because the velocity is 0. And afterwards, now be careful because it's going backwards, it's going to be 400 multiplied by my 2 times 10 to minus 26. And this one, I'm running out of space here, is going to be my 10 times 10 to minus 26 v, because I multiplied by the velocity. Therefore, if I put those two in, I get 12 times 10 to minus 24 here. Then it's going to equal minus 8 times 10 to minus 24. Multiply those two together, plus that 10 times 10 to minus 26 v. Now, if you take that across to the side, that then is going to be 20 times 10 to minus 24. Then that's going to equal to 10 times 10 to minus 26 v. If you put all that into your calculator, you'll find the velocity is going to be 200 meters per second. And it's positive, which means it's going off the right hand, well, going to go off the right hand direction. Now, you can finish off the calculation yourself. Now I've got the velocity of that. What you can do is work at the kinetic energy, or the total kinetic energy before of the initial one using a half mv squared. You've got the mass and you've got the velocity. Obviously, kinetic energy of that's going to be 0 because it's not moving anywhere. And work out the kinetic energy afterwards. Again, use half mv squared. You've got the mass, you've got the velocity of that one. And this one again, now we've got the velocity because we know now it's going to be 200 meters per second. And we can work out then the kinetic energy of this one. Now, because kinetic energy is scalar, you just add up the two numbers. I know it's not going to be a total inelastic because they're not joined together, therefore it's definitely elastic, but I can work out is going to be a partial elastic collision or not. If it's going to be elastic collision, kinetic energy is conserved. If it's going to be partial, kinetic energy is not conserved. I'll leave you to work that out and find out yourself. So, summarize what we've done. We've been through these learning outcomes. So we have battled our way through. We now know what was meant by the principle of conservation of momentum. We've done calculations, and then we've done examples of elastic, inelastic, and partially inelastic. And now we're starting using kinetic energy in these three types of collisions. Hope you enjoyed the video.